Good morning, everybody. We'll begin today's session. Yeah, this is the first question for the day. Here, what you're given is you're given two perspective views of the same object as shown here. Okay, there are two perspective views of the same object which are provided here, view 1 and view 2. What do you have to, or I'll say, let me say view A and view B. Count the number of surfaces that are there in the figure, in the object. You have to assume hidden surfaces to be flat. So in this case, let's count it. We'll start with view A first. Okay, I'll try to count the surfaces that are on one side and then I will move to view B. Why? Because view B may, at least you are shown in view B, at least you are shown the other side. So this part of the bottom is shown here in view B. Okay, so we'll count it now. 1, 2, 3. Just a second. 3, 4, 5, 6, 7, 8, 9. This whole surface will be 10 and this is 11. 11? I've reached this to this point here. Okay, this is the 11th surface which was there. This is 12, 13, 14, 15, 16, 17, 18, and this whole thing is going to be the 19th surface. This is the 20, the top part. Sorry, this is the 20, sorry. This is the 20. This is 21. This is 22. And this whole surface is going to be 23. So the answer is 23 surfaces. So here what you're provided is, all right. So here in this question, what we're given is, we're given an image that is made out of separate pieces. What you have to find is the least number of pieces that are needed to be moved, rotated, or flipped or flipped for achieving symmetry about the central axis. Here, I want to get symmetry about the central axis. Now, here in these kind of questions, we're just going to run around looking at both the sides for finding the number of pieces. It's going to be a little bit problematic because you'll waste a lot of time and you might end up repeating few pieces. So what is the thing is, keep one side, say I keep the left side as a reference. I keep this as a reference. I'm not going to find any pieces here. This is just my reference for comparing. And I'm going to find all my pieces in the right side part. All right. So I'll go from top to bottom. It's much ideal to go from top to bottom. And in some cases also from the left to right. Like in case of these columns, I cannot go from top to bottom for each and every part, comparing everything. I'll rather go from column by column. So till so much part, I'm going to go from top to bottom. And then after that, I'm going from left to right, column by column. So in this case, the first piece which comes here, which of course is different than this piece, but a similar piece we also see at the bottom, which is again different from this piece. What it means is both the pieces have been swapped. They have been moved, which means this piece as well as this piece needs to be moved and their places needs to be interchanged with themselves. So this is one piece and this is the second piece. Further, the eye part, this part is also different. So this will become your third piece, which needs to be rotated. All right. Rotated clockwise, 90. Further, this part is fine. When I go check all these pieces, they appear fine. But when I compare the pieces which are happening in this row, in the second row, what I find is this is fine. This piece and this piece, the positions have been interchanged. How they appear here? One is here, ये वाला piece जो है आपका वो यहाँ पे है और ये वाला piece आपका यहाँ पे है. So the both of the positions have been interchanged. So this is the fourth and this is the fifth. When I move further, these two pieces are fine. When I move to the next column here, This is fine. This is another piece and this is another piece. Now, if you look at it, both the pieces have also been interchanged because on your left side, which is the reference figure, the one piece which has this flat end is coming at the bottom and the pointed end is coming at the top. So even the 6th and the 7th piece are here. Further, in the next column here, we also find an evident thing, which is this piece and the position of these pieces. Even these two pieces' positions have been changed. They happen here like this and this. It is very evident that they have been interchanged also. So the total pieces that have been interchanged are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the correct answer is 9 pieces. Here, what we are provided is there's this guy Shyam who runs a dairy. In his cattle herd, each white cow gives 12 liters, each brown cow gives 7 liters, and yellow cow gives 10 liters of milk daily. He had drawn a sketch of his herd, which is shown below. Using the sketch, we have to calculate the amount of milk produced by his dairy per day. We have to find the amount of milk produced per day. Now, what we have to first bifurcate, there are two kinds of cows. There are two kinds of animals which are shown here. One is a cow, which has this kind of a system. We are more interested in that cow itself. We are not interested in counting other animals. So first we are going to take count the number of white cows. The number of white cows are 1, 2, 3, 4, 5, 6. 6 white cows. 6 white cows. One white cow gives 12 liters. So 6 into 12 is 72 liters of milk. Then we are going to go for the brown cows. The brown cows are 1, 2, 3, and 4. The 4 cows multiplied by every brown cow gives 7, 28. Then we are going for the yellow ones. For the yellow colored ones, the number of cows are 1, 2, 3, 4, 5, and 6. So 6 into each yellow cow gives 10 liters, which is 60 liters. When I add all of them up, 72 plus 28 plus 60, I get 160 liters, which is the total amount of milk produced in a day in the dairy of Shyam. The figure shows two concentric equilateral triangles with a circle within such that the circle touches all the edges of the triangle. If the radius of the circle is √3, what is the total length of the star-shaped outer boundary? We are interested in finding the shape of the star-shaped outer boundary, this outer boundary. I'm not interested in finding the internal dimensions. I just have to find the star-shaped outer boundary only. Now, in that case, further, another thing which one can also notice in this figure is the central part, which is getting formed by the intersection of the two triangles, is a hexagon. It's a regular hexagon with all the sides as equal, which are drawn in blue. Also, I am provided is the radii. I'm also given the radius. So what I'm going to do here is I'm going to take this triangle. Why I will take this triangle is because look, this blue line is a regular hexagon. Further, if it is a regular hexagon, when I extend both the edges outside, the resultant triangle that will be formed here will also be an equilateral triangle. In an equilateral triangle, all the sides are equal. When all of these sides are equal, and also ये वाला जो part है, point मिलेगा आपको, let's say this point A, B, and C, and this point is D. In this case, A becomes the midpoint of the lines AC, and sorry, A becomes the midpoint of the line CD, and CD is also equal to, say, I'm saying X. CD is also equal to XD and XC dimension because it's an equilateral triangle. XDC is an equilateral triangle. So in now, I also know that the angle of a hexagon is 120 degree. And C में से BC वाला जो angle है, that bisects that angle C, which means ये वाला आपका जो angle होगा, that has to be 60 degree. Okay. Now, if this is 60 degree and this is a right angle triangle, I can apply tan 60 here in triangle ABC. Tan 60 degree will be equal to AB, which is AB ka value I know, √3, which is the radius of the circle. I'll just write here AB upon AC. AB ka value is √3 upon AC. Tan 60 value is also √3, which is equal to √3 upon AC. Therefore, the value of AC will be 1. Now, CD is equal to twice of AC because A is the midpoint. Therefore, 2 into 1, the value of CD will be 2 centimeters. Therefore, आपके सारे edges, आपके सारे triangle के ये जो भी sides है वो सारे 2 centimeters होंगे because they are all equal and they are equilateral triangle because अंदर वाला जो blue part है that's a regular hexagon. So the required length that we have to find will be, now this boundary has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. It has 12 edges. So 12 multiplied by one edge of 2 units, which is equal to 24 centimeter. A solid is drilled using a cylindrical drill in a direction as shown in the below. As shown below, how many surfaces will the solid have after drilling? How many surfaces will the solid? So here we are interested in finding the total number of surfaces generated. All right. So first thing first, this is a cube. So a cube definitely will have 6 surfaces. In addition to the 6 surfaces, we also need to count the surfaces that are existing drilled. So plus 2. Okay, we are there now. So how is the drilling done? Let's take the front view as a reference. Okay, I'm just trying to draw the drilling lines which are going to run through like this and like this. In this case, if you just look at this junction, this part is partially getting intersected. It's partially intersecting with the drill part. Also, from the back side, it's just a small drill, circular drill, which is getting out. What it means is that this part, this puncture which is existing, won't be dividing the drill part into multiple components. So in the drilling hole will be happening in this part, which is one part. This is one circular cylindrical surface, and there will be a continuous cylindrical. This will be the second continuous cylindrical surface. There won't be a third cylindrical surface which will be divided by this existing cutout. So plus 2 for the drilled surface. When you add this thing up, the total number of surfaces that the solid will have after drilling will be 10, which is the correct answer. Here in this case, we are given 3 transparent glass pieces with different engravings, and they are to be overlapped one on top of each other with this red corner as a reference. What is the total number of triangles that the resultant figure will have? Now, when I just draw the overall surface that will be formed, once we have overlaid everything, this is how the figure will look like. So, this. There will be this part, and then there will be the surface. Further, besides this, there will also be lines which will be running like this and this. And this is how the whole surface. I'm just redrawing certain existing lines just for reference, so it's clearly visible. This is how it is going to happen. Please note, in this edge, we don't have any intersection, okay? So what we are interested in finding is the total number of surfaces. Now, just for my ease of counting, I'm just going to redraw this again here also. And here in the other part also. So it becomes easier for me to draw and show you the various possibilities. So these are the way in which the intersection will happen, and this is how the final figure will look like. So here the total number of triangles that are formed are. So I'm just going to take one quadrant so much first. We'll take the other quadrant also, this one, later on. Okay. The total number of surfaces in this quadrant are 1, 2, and 3. 3 here, 3 here. The total number of surfaces in the other quadrant, which are drawn here, will be 1 and 2. And here also there will be 2. So the total number of surfaces so far that we have calculated are 3 plus 3 plus 2 plus 2, which is equal to 10 surfaces. Then we are going to look at the other surfaces that are found besides this. First, we are going to take this innermost square, which has a box and then this square. I'm going to count the total number of triangles in this part, which are made up of 2 triangles, which means this 1, 2, sorry, 3, 4. So 4 plus in the same manner, when I take this outer circle, outer square with the intersection. Now what I'm talking about here is taking the outer square as like this. Of course, there will be inner square which will be happening here, but we are not looking at it. We are looking at the larger triangle. So 1, 2, 3, and 4. So 4 such triangles here also, which will be equal to 8. Besides this, now I'm going to take the outermost circle, this bigger circle. In this circle, sorry, the bigger triangle. In this triangle, there will be 1 and then there will be 2. So here we have only 2. So 10 plus 8 plus 2, which is equal to total 20 surfaces in this diagram. So here, now in the next figure, now the next question, what we are provided here is, we have given here a figure which shows which shows a hinged structure. What is a hinged structure is these are not fixed joints, but they are movable joints.
When I push it inside, the shape can be deformed easily. The structure can be elongated and compressed. So I can elongate the structure, I can also compress the structure. It's like those snake toys which we used to get. As shown in the figure, the distance between B and Q is 150 root 6, which is already provided here. When the angle ABR is 90 degree, when this is 90 degree, which means all the angles are 90 degree. Why? Because opposite angles, they are equal. So that's why all these angles will also be 90 degree in that case. What will this distance BQ be when the distance between the angle ABR change to 60 degree? When 90 degree becomes 60 degree, what will be the new dimension be? So what I'm going to do here is I'm going to first find what is BE, because it becomes easier for me to take one square at a time or one parallelogram at a time and then decode what will the new distance BE be and then multiply it by 5 times so that I can get BQ. Why do I multiply it by 5 times? Because BQ total is made up of 5 components, 1, 2, 3, 4 and 5 components which are equal to the length BE. Because BE is equal to EH, which is equal to HK, which is equal to KN, which is equal to NQ, which are the 5 different lengths, which BQ is made up of. Therefore, if BQ will be equal to 5 times BE. I know the dimension of BQ, which is 150 root 6, which is 5 into BE. Therefore, BE will be equal to 30 root 3. So far I've found this, okay? Now in this figure, what we are also provided is, we don't know, we are provided here, now I'm just going to take the parallelogram BDEC. B, D, E and C. This is 90 degree, okay? This is 90, this is 90 and this is 90 and this is also 90. In this parallelogram BDEC, I know the size BE. I know the angle DEC. If I take this diagram like this and I demarcate the new point generated X, the new angle XED will be 45 degree because this is the diagonal BE which will divide the angle E into 2 parts, which is bisect the angle 90 degree into 2 parts, one of 45, also another of 45. Therefore, now why I need to, now in this case, if you look at it, the stick sizes won't change, but the inner size, the BE dimension will change. Why? Because as the angle changes, this dimension changes. But the stick is going to remain constant. It's not going to become big. So I need to find DE as a size. What is the size of DE? In order to find the size of DE, I'll take the triangle XDE. In that triangle XDE, I have the value of XE. Why I have the value of XE? XE will be equal to BE by 2, which is 30 root 3 by 2, which is 15 root 3. This is all I know. So what I'm going to do is I'm interested in the hypotenuse DE. So that's why I will take the value of cos. So cos 45 degree will be equal to XE upon DE, which is the hypotenuse. Cos 45 value is 1 by root 2, which is XE value we have replaced here, which is 15 root 3 by DE. Therefore, DE will be equal to, sorry, cos, yeah. So therefore, DE will be equal, this is root 6. This is root 6, sorry. I did this mistake here, yeah. So therefore, DE will be equal to 30 root 3. I so far found the value of DE, which is the stick size, one stick size, which means all these stick sizes are equals, which means all the stick sizes are going to be of 30 root 3 in dimension. Once I have found the stick size, I'm going to this new situation where the angle ABR changes from 90° to 60°. In that new dimension, the parallelogram BCDE will look something like this, where this whole angle is 60°. When I draw that same point X here, this angle will be 30° because it's a diagonal divided into two parts. I know the stick size. This is D, this is E, this is C, this is B. This dimension DE I know, which is 30 root 3. I don't know XC. Therefore, how do I find XC? I again take the value of cos 30°. Cos 30° is XE upon DE. Cos 30 is root 3 by 2 is equal to XE value I have to find. So XE upon DE value I know 30 root 3. Therefore, XE will be equal to 45 units. I know this is 45 units. XE. So if XE is 45 units, which is X point here, therefore, BE will be equal to twice of 45 units, which is 90 units. Therefore, the total dimension BQ, which is equal to, 5 times BE, will be equal to 5 into 90, which is 450 units, which is the answer. Okay. I'll take that question the next time. I'm sorry for that. This one. So here, what we are provided here is we are given an equation, 1, 2, 3, 4. We are given 4 equations. What we are given is this equation corresponds to 1 plus 4 is equal to 5. Now, what we are provided is in a new form of decimal system, the numbers 0 to 9 are represented by a new set of symbols which are provided here. One example is given here where first equation is 1 plus 4 is equal to 5. If in the solution of if in the solution to equation 4, this one digit appears twice, which number will replace the question mark is what we have to find. Which number will replace the question mark? So what I'm going to do is I'm first going to write the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. What I know is 1 looks like this, 4 looks like this, and 5 looks like this. I don't know anything else, okay? So I'm going to now move to the next equation. If 1, 4, and 5 looks like this is 4. This is 4 plus single digit number is equal to another single digit number. So which are the various combinations which equal to a single digit number when you add 4 to it? So it could be 4 plus 2, which is equal to 6. It could be 4 plus 3, which is equal to 7. It could be 4 plus 5, which is equal to 9. It cannot be 4 plus 6 because 4 plus 6 equals 10. So these are the various combination possible. Now, the last equation is not possible. Why? Because we know what 5 looks like. 5 looks like this, and this is not 5. So we are not considering that. So either this symbol can be 2 or either that symbol can be 3. Either or that. Now, if I'm going to take the latter part here, I'm going to tell you why I'm taking the latter part. I'm not this one. I'm assuming that this symbol is 3. I'm saying this is 3, and which means this has to be 7. Which means this may be equal to, so 3 has to look like this, and 7 has to equal to look like this. Now, if I'm taking this as an assumption, and in the next part, we'll see how. The next part, 2-digit number minus a single digit number will be equal to 1 and something else. Two-digit number and a single digit number has to equal to 1 and something else. Now, obviously, like without any thought, this cannot be 30. 30 minus single digit number cannot be equal to, cannot be equal to 1 and some digit number. That's not possible because 30, even if you do 30 minus 9, it will be a two-digit number which is equal to 21. So definitely this cannot be 3, which means 3 has to be this. So our assumption stands true that 3 and 7 will be represented by this number. Okay. So far, which means this has to be 2. So it has to be 20 minus a single digit number equal to 1 and something else. Sorry, 14, not something else. I'm sorry, 14. Which means this is 2, which has to look like this, and 6 has to look like this. 20 minus 6 is equal to 14. This we already know. So far, we are fine. In the next part, what we don't know is 8 or 9. 8 or 9 is something which is not known. But what we have provided here is this is 3, this is 1, this is 3 plus something, and 6 is equal to the final equation. So we are going to try both the additions. 313 plus 86 is equal to what? So 313 when you add with 86 equals 399, and 313 plus 96 will be equal to 409. It can be an either or situation now. Either it is for 399 or 499. But what we are given in the question is this part. If in the solution to the equation one digit appears twice, which means 409 में कोई भी आपका digit repeat नहीं हो रहा है, so that's why it's not possible, which means ये वाला आपका figure है has to be 8, and it has to be 313 plus 86, and the resulting answer that we are looking at is 399. Okay, which means 8 in this diagram will look something like this. This you don't have to decode, that's okay, but I'm just writing it for our purpose. That's okay. Okay. So the answer is 399. What you are provided here is, what you are asked is, what is the maximum number of whole cuboids of length 2 by 1 by 1? 2 by 1 by 1. That can fit into a cuboid which is of dimension 11 by 3 by 3. Eleven by 3 by 3 is the dimension which is provided to you, which is a long dimension. Okay. आपको बड़ा सा cuboid दिया है यहाँ पे. This is an exaggerated length. It might look something like this. Anyways, so what we are interested in is how many such cuboids can this whole dimension fit. This is 1, 1, and this is 2. Now here I'm more interested in finding in one slice or in a one box dimension of 3 by 3 by 3, how many cuboids can I fit? Why? Because the base dimension is a 3 by 3, the height is 11. So in a 3 by 3, how many such units can I fix? Now one option can be literally, which I tried and it works out, was also taking the dimension in interlocking manner like this, where this is 2, this is 1, this is 2, this is 1, this is 2, this is 1, this is 2, this is 1. What it leaves out is this void of 1 by 1 centimeters. Now, if I'm saying that, and then of course, the height of this size will be 1 centimeter. ये आपका 1 centimeter का height यहाँ पे आएगा. So I'm going to say that, okay, this 3 by 3 by 1 module, how many such modules can you stack in a height of 11 centimeters, which means it will be 11 modules multiplied by 1, 2, 3, 4. 4 parts in one module, which is 44 units. Besides this, I'm left with a void, which is 1 by 1 by 11 centimeters in height. It's a 1 by 1 by 11 centimeters in height. Now I'm assuming that what if I add 2, ये वाला जो 2 by 1 का जो यूनिट है vertically along the stack, यहाँ पे vertically बीच में वो stack में वो arrange हो जाएगा. What if that happens? What it means is that if this is 2 centimeter and the total dimension is 11 centimeter, 5 units of 2 by 1 can be fitted vertically in this void which is getting generated. So 44 plus 5 units getting added in the void, which is equal to 49 units total. Here, what you are provided is, you're given this diagram and you have to find how many triangles are there in the figure provided. This is how the total number of triangles in the diagram will be 40. So in this case, what the first thing that I did was, I said that, okay, because this is a symmetrical figure, let me divide this figure among the top half, because the bottom half is going to be exactly the same. So I'm saying, let me first do this and try this exercise for these 3 different relationships. So in the first case, I'm finding all the triangles that are there in the first half, which are 12. 1, 2, 3, 4, 5, 6 triangles. 6 into 2, because yahi 6 triangles niche bhi honge. Let's make it 12. Then I'm saying, okay, what if the triangles are multiples of 2 or a combination of 2 small triangles? वैसे आपके पास 3 triangles है, 1, 2, 3. So 3 वैसे ही नीचे भी 3 आएंगे. So this is 1, this is 2, and this is 3. So 3 multiplied by 2, which is 6. Further, I checked out, okay, what if now I start looking at triangles that are made up of combination of 3 small triangles. So 12 पहले आया, फिर 6 आया, उसके बाद मैं 3 combination वाला देख रही हूँ. So that will be 1, that will be 2, three, and then 4. Okay, so 4, एक half में 4 दूसरे half, मतलब 4 into 2, 8 units. So far I will reach 12 plus 6 plus 8. Now then I'm saying, okay, forget that symmetrical line. Now let's look at the combination triangles also, which are bigger. Now the triangles which are left in the middle are, these 2 triangles had not been counted. So these 2 plus 2 triangles. Besides this, ये 4 corners के ऐसे बड़े वाले triangles होंगे on all the 4 sides. Plus I will have these big triangles also, which are drawn here. 4 triangles. Plus I will also have these triangles. These triangles. 1, 2, and then 3. And 4. So these 4 triangles also. When I add them up, 12 plus 4 plus 4 plus 6 plus 8 plus 2 plus 4, I get the answer as 40 units. So here you are given a grid of squares which are shown in the figure, which are to be tiled, with the tiles shown in the options provided. The covering tiles must not overlap and should not have gaps around them. There should not be gaps and they should not overlap. Only 4 tiles, which are these 4 tiles in the middle, are to be not tiled. They are to be left open. Once a tile is chosen, other tiles must be of that type only. Tiles can be flipped, rotated if required. Which of the tiles can be used to tile the given grid is what you have to find. So here, we'll try to make up a combination like this. First, I'm going to take A and B are not possible here. First, I'm going to show you how C is possible. C may, this is one tile. Okay, as you can see, this is one tile और वैसा ही उल्टा दूसरा tile है. When you come overlap each other, we get a grid of 4 by 2. This is a 4 by 2 grid, which is what is shown here. This 4 by 2 grid would be placed like this in the given figure. Okay, which means that C is possible. C is one of the answers. Then we are going to look at the next part, which is also the possible, which is option D. In this case, what I have done is I have actually mirrored this part, mirrored this grid like this, and then placed on top of each other. What it means is case may this is the original option which is given here, which is this one. और उसके ऊपर जो black वाला part है is what the mirror which is placed. This also forms a 4 by 2 units, and we are going to place it how I showed you earlier, like this. This is a 4 by 2 unit. Okay. So both here C and D are the correct answers. Here in the next question, we are given tile X. Tile X is used to create a seamless pattern when arranged as shown below. Which tile or tiles from the option will create a seamless pattern without any gaps? Without any gaps, like how it is shown here. Here in this case, this is, I have drawn here, I have repeated the pattern. This is option A. In case of option A, if this top part was a triangle, like how you're seeing here, which is a gap, only then interlocking is possible. Otherwise, A में interlocking possible नहीं. In case of option B, we actually need another module of this size to fit inside to create a seamless pattern. So B be possible नहीं. In case of C, this is how the interlocking happens. In the case of interlocking, just observe one thing, that आपको ठीक efficiently interlock करना है, तो इसका position में you rotate it 90 degree here, इसका भी आप rotation 90 degree करो, इसका भी rotation 90 degree करो, और इसका वापस 90 degree यहाँ पे rotation आना चाहिए. When you do that, and then when you try to fit in each other, all the pieces together, then if there are no gaps left, only then interlocking is possible. So C में वो interlocking possible है. ये D वाला part है जिसमें भी वो आप देख रहे हो ये वाला module repeat किया है. So this is how that module happens. और वो 4 वाला जो repetition है वो इसके along हो रहा है यहाँ पे. I'm drawing the module of the 4 interlocking repetition once again. This is the 4 interlocking repetition. इसका 90 degree rotation here, इसका 90 यहाँ पे और इसका 90 यहाँ पे. So B, C and D are both are the ones जिसका interlocking repetition possible है. A में if this part was a triangle, only then it's possible. If one part needs to be added or some part has been overlapped here, only then repetition is possible. Otherwise, नहीं possible है इसमें repetition. Okay. ठीक है. We'll end today's session with this. Thank you so much.